Hi, this is Christian with Chapter 6, Screencast assignment, where we were asked to find the coefficient of friction between the person's shoes and the ice, and between the car's tires and the ice. Here's my work on how I did it. So, I started first by listing all of our knowns. The initial frame was 30 frames, and the final frame was 110. We know that the final velocity was 0 because it came to a stop. We also know that the total distance that the guy slid across the ice was 7.5 meters. I also listed my unknowns, which was acceleration in the x direction, our time, and the coefficient of friction. So I started first by finding time. I knew that I subtracted 110 frames from 30 frames, which was a total of 80 frames, and then I simply divided that by the rate, which was 30 frames per second, and that's how I got 2.67 seconds, which was the total time that the man slid across the ice. Then I started by finding the velocity, which I just used distance over time, which was 7.5 meters divided by 2.67 seconds, which gives you 2.8 meters per second. And that's the delta V. And you can simply find the initial velocity by rearranging the formula delta V equals VF minus VI, which just equals to negative 2.8 meters per second. Then I found the acceleration by the formula VF minus VI equals TF minus TI, or delta T, and that's how I got 1.05 meters per second squared, which is the acceleration. Then I also drew a free body diagram to help me visualize the forces. Here is the free body diagram before the man started sliding, and this after. So at the point where he no longer is running and just is completely sliding, the only three forces acting on the man are the normal force, the weight, and the friction. In this case, it's kinetic friction. Then I continued on to find the coefficient of friction by using the formula Fk equals negative ma, because you need to know Fk before you can find the coefficient of friction. And you know that the normal force is the same thing as the weight force, or m times g. And here, if you arrange the formula Fk equals uk times n, you get that the coefficient of friction equals the kinetic friction divided by the net force, or negative ma divided by mg. The masses cancel out, and you're left with the accelerations. And although you have a negative acceleration in the x direction, that does not matter because the coefficient of friction is always positive. So here the final answer is 0.107, and that's the coefficient of friction for between the man's shoes and the ice. And then we go on to finding the coefficient of friction between the car's tires and the ice, and it's the same thing, just different numbers. I started by listing my knowns. We know that the initial frame is 55, the final frame is 140, the rate is still 30 FPS, the acceleration in the y direction is 0, the total distance the car slid across the ice was 8 meters, and you know that the final velocity is 0 meters per second. Our unknowns are the net force, the frictional force, the kinetic friction. We also don't know the coefficient of friction, which is what we need to find. We don't know the acceleration in the x direction, or the total time, or the initial velocity. Here I did my coordinate system. which is the basic up is positive, to the right is positive, and that, and a free body diagram, which is the same as the man's. Then I started by finding the time, which was 2.83 seconds. Then I went on to finding the velocity, which is 2.83 meters per second, and that is the same thing as your initial velocity. And then to find the acceleration in the x direction, this time I used the formula vx squared equals initial velocity squared plus 2ax times delta x. I rearranged that formula to solve for ax and plugged in my numbers, and the acceleration in the x direction is 0.5 meters per second squared. Then over here, you know that the net force is equal to weight, or m times g. You know that the kinetic frictional force equals the coefficient of friction times the normal force. And here, you know that the total sum of the forces in the x direction equals negative kinetic friction times ma, or Fk equals negative ma. And then if you rearrange the formula for the coefficient of friction and you plug in your values, the masses cancel out, so you're just left with the acceleration in the x direction divided by gravity, and your coefficient of friction between the tires of the car and the ice is 0.05. And that is how you find the coefficient of friction.